So I think we can start. During the last class, we stopped after we learned about the if-else conditions, right? So far we learned the since out, input-output, and the data types, binary system, operations, if-else conditions, and now we are going to learn about for while loops. So let's start. So let's see. We'll start with the question. For example, let's say we have to output numbers from 1 to 100. Any ideas how we can do this? Yeah, any idea?
Use MI to count numbers, or like how many times it has output numbers, and when it goes to 100 and so on.
But we don't know about for or while, right? Yet. So the option that we can do, for example, is to print 100 times in the code cout 1 cout 2 and so on, right? But it's not that like we can't do this, right? So for this we have the idea of loops, some structure that allows us to do some repetitive let's say action. And for the loops, let's start with the while, because we have different types, right? So let's say as in the previously, we would have like while if and then like brackets, the like main body of the if, and then here we would have the condition, right? For the while, it is similar in some way. It's a while, right? And then after that we have this type of brackets again, and after again this type of brackets. And here again this is some condition, which I'll explain now. And then here this one is the body of the whole thing called while, right? We type the code that is related to while over here. So how do we understand this, right? So the while, as it says from the word, does something while the condition is correct. For example, let's say we have some int equal to we have some e equal to 0. If you write, for example, while while e is less than 100, right? And then in the inside we write like e plus plus, which means like e equals to e plus 1, basically. This is just a comment. So if we do this, right, what are we trying to do? We are entering the while, and as we enter the while, the condition checks itself. So the while checks if the condition is true, so it can enter the while. So I is less than 100, which is correct, and then we enter the while, right? After that, it does the main body of the whole while, some operations, not necessarily those. As for example, in this case, it does just adds 1 into e, right? So 0 becomes 1, like basically. And then after it finishes and reaches the end of the body, right over here, it goes up to check the condition again. And again, e is less than 100, right? And then the condition is correct again. It continues the same thing while the condition is true. And then let's say we continue the same way and we reach, like, I don't know, 98. E is equal 98, right? So later it goes here, it checks here, e is equal 98. This is correct, right? And then it continues here, it comes here, it says this. So e becomes 99, right? Okay. And then after it reaches the end, it goes again. 99, the same, correct? Goes, adds 1, it becomes 100, and it reaches the end. It goes back again and checks if the condition is correct or not. The condition is not correct because 100 is not less than 100, right? So in the case of it not meeting the conditions here, it doesn't continue anymore, because the whole purpose of while is while the conditions work, it continues, right? So while this worked, it continued, now it doesn't work, it stops. And after it stops, it continues from the end of the body, from here, and executes the whole program as it is normally later. So let's see what we can do. Can we, for example, knowing this, type at first, let's type all of the numbers from 1 to 100. So for that, what are we going to do is so for that, we first initialize the e equal to 1, right? And while e is what? We have to print from 1 to 100, right? Yes, or less than equal 100, right? And then out e, and then if you want to maybe make a space between them, we put this, right? The space character between. So every time it is going to print number, for example, like 1, and there's going to be another thing printed, just empty space character, right? And then after another thing and another thing, like this, right? So I think that's it, right? Let's see. That's correct, right? So here we just have we have infinite I ones, right? So we do e++. Let's try again. And we got every single number from 1 to 200, right? That's good. So before, I forgot to add e plus plus, right? What happens in this case is that, well, let's see, while e less than 100, cout I, right? So in this case, well, it does cout 1, right? It does cout I, but the condition is I minus 100. In this case, it enters with the correct condition, I being less than 100, but then the I never changes inside, right? So apparently we end up having a limit loop, which doesn't break, like it doesn't, like it's on limit, right? It just goes this. It just continues over and over. So we are stuck there, right? This is bad. We have to be careful to not be in these cases, because otherwise we are just going to make our program stuck somewhere, and then this is like TLE, which is time limit. Basically bad. And then we have a question. Okay, no questions. Not yet. So let's say we want to print numbers from 1 to 100, but only the even numbers.
1 plus 2, y equals to 1 plus 2.
So
Let 1 begin from 2, and then y equals to 1 plus 2.
So you're saying that we can do equal to e plus 2. And then we also change the beginning because it would be odd numbers, right? Because, for example, now we printed all of the odd numbers, right? And then, for example, if we change the beginning part, we would get all of the even numbers from 0 to 100, or if we want from 1 to 100 range, we just do 2. That's also a way, right? But then, for example, if we want to, let's say, print all of the numbers from 1 to 100, that you can divide basically for all of the numbers. We have to print all of the numbers that are in this range, and then when you divide the number, for example 2, 3, you don't get any left over, right? So it's purely divides by 3. Basically x modulo 3 is equal 0, right? And then also print numbers that x modulo 5 is equal to 0.
And put if inside the while.
We have to put if inside the while, yes. So we have to print basically like 3, 5, 6, 9, 10, right? 12, 15, 18, 20, right? And so on. So here we were able to easily make a pattern and then continue. But also we can have, for example, if inside, right? We are not limited with this. We can write whatever. So for this, we can write if. If what?
X modulo of C equals 3, 0.
If x modulo x in this case is I modulo 3 equals to 0, then what?
C out I and the blank space.
That's it. So here we are getting all of the numbers. No, we're not getting anything, right? Why? Because we forgot to change I, right? So we have to also add the change of I. Right? So we got all of the yeah, but it's not supposed to be necessary because it's only one line, right? Oh wait, sorry. Yeah. I think it was not saved or something like that. So here, for example, if we have this, right? It still works because it's only one line, right? But again, it's kind of a thing. You can also do that if it's like only one line after. Anyways, so here we got all of the numbers. That are divisible by 3. Right? But then the condition was different. We have also we have to also include all of the 5k. Basically, we have to include 3k or 5k looking numbers of this form. And which is which one? And the 5 0. Is this correct? Let's see what we get, right? So what's the problem? Because we did and we got all of the numbers that are in the form of these and these at the same time, which is 15k, right? We got all of the numbers 15, 30, 45, 60, 75, 90, right? So to get separately, we have to put or, right? What do we get? I think that we want. Nice. So there is another form of let's say the loops, right? So here it's the start is like this, the condition is this, and the update is this, right? For the E. But we also can have a different thing called for. For looks similar, but at the same time different. we also have the name, like as for example while for, right, the bracket and the other type of the brackets, right? But then here it's not just only the condition. Here we are going to write three things, three parts. It is going to be let's see. It is going to be the start, the condition, and then the update. So, for example, here the start was, we set the E something, right? The condition was this until blah 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 blah, and then we update it like this, right? So for 4 we are doing the same, but in the actual brackets, as for example int E equals to 1, and we separate with this symbol. This is the syntax. And then we add the condition, which is, for example, E less equal 100, right? And then after we add the update, which is the change of I, for example, E plus plus. Right? We just add one. And then we write the code in the body, as for example, cout I. Let's run. And we got numbers from 1 to 100, right? Because we set start as, we initialize the E, int E, right? And then we add the, like, the condition and then the update. And then how it works is that it comes, oh, I changed my thing. It comes, sorry. So we have the 4, right? Int E equal to 0, E 100, and then E plus plus, right? And then right? The body is here, and then this is the whole 4. So how it works is that it comes, right? And then it sees this. It does this. And then it checks the condition. If it's true, it goes inside. Goes inside. Does the stuff inside. Comes back. Checks the condition again. Does the change and change the condition. Check the condition. And then as if the condition works, it goes inside again. For example, if we have E equal to 0, it goes inside, it's like it see out the thingy, and then it continues, it goes back, and then E becomes 1, right? And then as it is still true, it goes inside. So apparently we have the same thing as well, but instead of us doing this and this separately, everything is just like here. And then we can also do E plus equal 2. And then we get all of the odd numbers, right? we can completely remove this, and then int e outside, let's say, why not, and then it will still work. We can also remove this, and add it, for example, here, and it will still work. And then we can also do this, right? So no start, no condition, no update, nothing, and it will still work. But we still have to keep these symbols inside, as for example 1, 2, 3 divisions, right? And if we don't, it is going to give an error, right? Because this is the syntax. Like, no matter if it's empty or no, we still have to put them, right? So, well, okay, maybe we have this, we don't really need it. It's going to run for a while, right? So now we also understand how for works, right? For in this case is just more compact if we are just running through, for example, for 1 to some n number or something. And then for while and both, like both for while and for, we have special operations. One is called break, and one is called continue. And what they do, for example, if we have let's say we have a case of like, okay, let's say we have to write a program that is going to enter numbers, right, from the person, like it is going to input numbers, and then it is going to check if the number is equal to, let's say 100, no, or not 100, 207 or something, I don't know. Or for example, if it is going, like, okay, no, sorry. So we are going to input numbers. Hello. For example, we are going to input two numbers, for example, x and y, right? And then we have to check, for example, if they are like equal or no. And we keep asking the person to input numbers until they are equal. So for example, we write like while blah, 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 right? And then here, well, what, right? We don't really know what we can, like, what I'm trying to say is that we not only can let's say condition the whole while with those brackets, but we can only also use, for example, break. What break does is, for example, let's say while 1, right? So while 1 means it is always true. It always satisfies the condition, right? And then, does it mean that it's going to work like forever? No, I stopped the program because I was the one who stopped the program. But if I didn't stop it, wouldn't. But again, let's just try to see out one and then see, like, it will work forever, right? Until I stop it. But then here is like, while one, this condition is always true. But there is also another way to get out of the while or for, which is break. If I write break, what break is going to do is it is going to break the loop. For example, while one, it enters cout one, and then it says break, it does break, and break just gets out of the body of the while. And if I had, for example, here like cout2, is it going to cout2? No, because as we see here, cout1 break, doesn't matter what is coming after, it already exited, right? Good. And then, for example, let's say we have, as I was saying, let's say write a program that takes two numbers as input, and then it only stops when it gets two equal numbers.
If x equals to y, break.
Right? So in this case, we are going to get, for example, 1, 2, and again it asks for a number 3, 9, again it asks for a number 0, 1, blah, 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 blah. And then we try, for example, 3, 3, it stops, right? But also, for example, we could write cout x and y, which basically just it gives the same number, or for example something else, as for example like found or anything, doesn't matter. So, but other than this, we also have another very helpful thing, which is continue. So what break does is it breaks from the while, right, or for. But continue, instead of breaking, it just jumps back to the condition, ignoring everything else. As for example, cout, let's think. Let's say we have like int e equal to 0, e less equal 100, right? And then cout, or no, e plus plus, right? Cout e. And then if I type continue, what continue is going to do is like it goes here plus plus, right? And then it says continue, it goes up to the condition, to the beginning, ignoring everything else after.
So like maybe nothing will appear. No number will appear.
Yeah, nothing will appear. Nothing, right? Or for example, if we change the places as, for example, cout, continue, and then e plus plus, it wouldn't reach 100. It would just keep cout 1, 1, 1 again, because we wouldn't reach the e plus plus. It would run forever, right? So what break does, we have the while, the body, and then some operations, some condition, And then in case of me, in case of us doing break, it just breaks the loop and continues the program. What continue does is that we have the condition, we have the thing, and then we have continue. And then maybe another things over here, but then how it works is that it goes condition body continue. Instead of continuing, going over there, it jumps to the beginning. Right? So let's try to write the program snippet that we have over here, which is let's say 4, we have 4, right? And then in 4 we have the start as e equal to 1, the condition which is e less equal than 10, and then e plus plus as the update, right? And then in the body we have if e equal to 5, break, right? Then if e modulo 2 equal to 0, continue. And then cout e. Can you tell me what it's going to output based on the code? So it will input as 1.
No, so when you reach 5, it will be 0.
So here we can see that it only outputs 1 and 3. That's correct. Because it goes, and then in cases of even numbers, it reaches continue, which just jumps back. So we never reach the cout part if it's even, right? And then for the odd numbers, it goes through this, and then it reaches cout, and then it outputs this, the number. But then when it reaches 5, it says break, and it just breaks the loop, and that's why we don't get like 5, 7, 9, nothing, right? So this is the principle how for while loops work, and also the break and continue conditions. So now, as we have the possibility of, let's say, running through things, right? We also have to learn how to store things comfortably to be able to run through them. As, for example, like, let's say the problem says it gives like 10 numbers, 10 different numbers, and then we have to output like every single number, but plus 10, plus 2, doesn't matter. So it says it gives like different numbers as x, y, z, blah, 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 blah. And then we have to output like x plus 10, 2, y plus 2, z plus 2, and so on. Right? So the way we can do that is just like, for example, with 4, right? Just like or just while, or just for example, for. So what I did is like I press tab, right, or just the whole structure appears, and then we put the type, we put the condition as, for example, from 0 to 10. Why? Because 0, 1, 2, 3 until 10 is 10 times, 10 numbers. So it will run for 10 times, right? And then I do sin int x, the number that I'm going to input the x, right? Then I output, for example, what? I output, for example, x plus 2, right? Okay, let's say I just to put space over here, right? So how it's going to look like? Sorry. How is it going to look like? It is going to look like this. As for example, I put 10. No, I put 5, 7. I put 8, 10. I put 0, 2, right? So it's kind of messy, right? So let's say we put handle to see more vividly what happens, right? So let's say we have 1, 3, 6, 8, 9, 11, 2, 4, 3, 5, 4, 6, 5, 7, 1, 2, 3, and then as we reach 10th number, it just ends, right? Correct. But then, do you see how like it works in a way of like every single time I enter some number and I receive number, enter some number, receive number, enter some number and receive number, and then everything is like separated, messy, blah blah blah, something, right? How can we, for example, have very clean, nice way, as I shown here, like one line of input, one line of output? So for that, we have to, for example, store the, let's say, store the numbers, like, collect the whole input, right? And then after, output. Because here, the program waits for new input to appear so it can output, and then waits again for new input and output, right? So until we don't output, it's not going to give new input. Sounds messy. So how can we store first and then output, right? For example, we could do x, y, z, a, b, c, d, e, f, something, right? Like a lot of variables like this, right? And then input every single one, and then output every single one with blah blah blah. No, right? So we have arrays. An array stores many values of the same type under a single name, laid out in a row, and then the syntax for this is And then we reach the element from the array by the index. Let's say, so the syntax, let's see the syntax. So it's also a variable, right? Like it's array, we have the name for it, right? We have the type, and array also has size, right? For example, 15, right? So instead, in the past we would do, like, for example, int x, and that's it, right? Here it also has size. And then we can have, let's say we created a list of elements called array, called A, which is kind of a row, right? With some boxes. And every single box is an integer, different integer, where we can store information. For example, we can do sin a0. What does this mean? Here, this is the size, but here this is the index. And in C++, indexes start from 0. The indexation starts from 0 and continues so on. Until the end of your array, right? So if we do sin a0 and then sin a2, we are going to have something over here and something over here, right? And then, or for example, we can see like a1, this element, right? Equal to a0 plus a2. This is also possible, right? So we just access the integers and do whatever we want, as we do like usually with just regular integers, right? This thing, it's the name and the index, which is kind of like a key to the list. Like it's an index to the box, to the section where we have the regular number, right? So, and then we can do, for example, cout a1. Let's see how it works. So, okay, we enter the first element, 2, and then we enter the second input to the A2, right? Which is, for example, 7. And then after it's going to do what? Yes. And then after we can do, for example, A4 is equal to a0 plus a1 plus a2, right? And in this case, we are going to have, oh sorry, we have to also output that, right? So we can see. So 2, 7, we got 9, and then we plus 2 plus 7 plus 9, we got 18, right? Right.
What if I only enter 2 and then plus enter?
Again?
What if I only enter 2 but I didn't enter the second number?
So it is, so how it works is like, for example, like 2, right?
It will ask me to.
It waits for your input, unless like it doesn't move until you give it, right? So this is a way to store information in a row very comfortably, right? And then reach it whenever we want. For example, the previous problem, as we were saying, about the numbers, right? We have to input 10 numbers and then output 10 numbers, but in a way of it being one row of input and one row of output, right? And we can do it, for example, like if we store everything, let's say, as an int EA of size, for example, 14, and then after we do scene, right? And then we have another 4, again with the starting from 0 and ending at 10, right? Because 10 times. And then cout e plus 2, right? Let's see how it works. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We forgot to have the space between. So again, so one line of input, we store everything and then we output everything, right? And then also, not only we can just input stuff, we can also initialize with stuff already. For example, like we were doing for example, 1 equal, we can do like, for example, this, right? Like we can set numbers, but then if you want to set many numbers at the very beginning, instead of doing like it one by one, we can also do this, which is int equal let's say right. It's not going to change anything because still we overwrite the information over, right? Because we do scene into the same boxes and then we just forget this, input no new information. But then if we don't have these, we would have, let's say we remove the plus because not necessarily, So in this case we are going to have 10, 20, 30, 40, 50, 0, 0, 0, 0, 0, right? Good. And then what happens, for example, if we don't have enough space over here? What happens if we try to access element index which doesn't exist? Let's say the size of this is only 7, right? And then here we would try to also output like A9, right? Which is way over. Let's see what happens. We get some random information, some random numbers, right? Why? Because in the brain of the program, A is here. We know the start, right? And then element, right? Element 1, 2, 3, 4, 5, 6, 7. And then what is after? Hmm?
Nothing.
Nothing, right? So if we look to this in a sense of like A, yes, there is nothing. But in the actual computer, well, memory is a huge line. And then when we do like A equal, when we do int A7, it chooses some specific part of the memory which is empty, and it allocates that memory to the variable, right? With the name of A start at some point, which we don't really know until we ask. Like, we don't care about that, right? And then with size of 7, right? But then if we try to access, let's say A10, right? Well, okay, we have the start, we have, and when we try to access this, it tries to access over here. But we don't have any control over that space. We don't even know what is there. It's just random information for us, which we don't even want to touch. And apparently it should actually, I think work as an error. I don't know why it doesn't work like that. Right? Let me check. So here, let's see. Okay. You see? Let's see. So yeah, so we have to be very careful with the things that we are accessing, right? Because in some cases it might give an error, in some cases it might work, but then we might by not knowing what, like, we have a bug, we might ask for some information from the place that there is nothing, and get some random information, and then the whole program just goes very wrong, right? So by selecting the size, we need to evaluate, okay, we are going to have this much information, so we have to make the array accordingly this much big, like with this some certain size. And here we can see it says index 9 is out of valid index range 0 to 6 for possible stack allocated buffer A, which means it warns us that we are doing something wrong, which here it doesn't. So, and we see that 10, 20, 30, 40, 50, right? And the last two elements are 0, 0 by default, right? Okay. Let's see. And arrays and loops go together basically. Like to go through the array, we have to use for example, to as we saw, input the whole array and then output the whole array or whatever, right? Or for example, we let's say the problem says we get some number n, and then we have to input numbers, n numbers, n times. And for that we have to first input the n, and then after have for, which would start from 0 to n, right? To have exactly n numbers. and then we do, for example, sin I, right? And then for this, like we have to also do the initialization part. But then, well, how do we know like the size of the array that we have to put, right? Because the way that the array works is that you put the size, it allocates the memory, and it's that's it. Like it's not dynamic, right? The default arrays are not dynamic. 8 is 8 enough? I don't know, right? And usually, for example, in some cases you would find in the problems, like in a statement, you would find limitations for variables, as for example, limitation for n. And it would say, for example, n is less than equal 200,000. So here you know that, for example, here you have to put 200,001 or something, right? But then there are some cases. Okay, wait, just a second, sorry. Okay, we'll just jump and go back. So there are some cases that, well, you don't really know what what size you have to put, right? You just have to have the ability to store some like a lot of information. But then if you don't know the limit, what you should do, right? So for that we have dynamic arrays. Dynamic arrays are so-called vectors. And vector just has the name, right? And you can put as much as information as you want. So the problem with A would be like with array, it's like it gives the memory in it allocates the memory like chunk, and then like you can't go over, you can't do anything, and then like it's not implemented, right? Like more information, more stuff. For vectors, for dynamic array, C++ it already has implementation of how like it manages the memory, right? Doesn't matter how it works right now. We might cover it later on, but doesn't matter. Like it's just very interesting thing to know. But again, we also covered during the data structure course. And then vector is just dynamic array which supports the operation of add, which is called pushback. So to use vector, you have to include vector, the library vector, right? And then the way we set a vector is vector, the type, which is vector, right? And then we put the type, data type of the element of the vector. As for example here, for the array, it's int, right? The data type. For the vector, we put in this type of brackets the data type of the elements, and we put the name as, for example, v. So now we just set vector with ints inside, right? And then to grow the vector, as for example add vector, to add elements into the vector. Yes. 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 To add elements to the vector, we have this operation called pushback. So the way you access to operations with vector is through dot, right? like in the past we would see like pair int a, right? And then like for example like p dot first, right? So here for vector we access operations again from dot, and then to add elements from the back of the vector we have to write push back. We push elements to the back of the vector, right? And for example 10. Okay. And then as we have one element inside, we have something like this. Only one element. And we can access that element as this 0, because the indexation starts from 0, right? Let's see if it works or no. So yes, it works. And then okay, if we try to access let's say not 0 but 1, we try to access the second element. There is no second element, right? So if we try to access second element, oh, we got error, right? The program just crashed. So we have to be very careful about the size, the limits, blah, 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 so on, right? Okay. So again, if we do, for example, another thing, for example, like 20, we would have already access to the second element because we have 2 elements, right? And we get 20. So how vector works is that vector can support operations, for example, adding from the back, right? We fix the beginning, and then we have things possible to be added. And then we can also pop, and we can also like remove from the vector, which is pop. Right? So what it does, for example, the vector was like 10, 20, right? Pop just removes the last element. So the vector is just 1, 10 inside. And we have a lot of like things with the vector, right? As we can see here. So let's learn the most important ones. For example, we can do size. What it does is it gives you the size of the vector. As for example, if we see out the size, we would see that, okay, no, because it was mixed with this. We would see that the size is 1, right? If we have one input, like one push and then one pop, we can see the size is 0, right? Well, what happens if the vector is already empty and then we try to pop something from it, right? Like it's already empty, but then we try to remove some element. It will give an error. So again, we have to be careful. And then how can we, for example, clear? How can we like completely empty the whole vector? Let's say we have like again we have n, we input n, and then we add n elements inside, right, to the vector. So we inputted n, right, the amount of elements, and then x is like the each element, right, and then how do we add it to the vector? So we dot pushback x, right? And then, well, okay, let's do something with it. Can we, for example, print the whole thing? No. Can we calculate the whole sum of the vector? So we go again through the vector, right? We already stored the information. We know that there are n elements, right? And then we do sum plus equal the e, right? The index. And then we get the sum of the whole vector, which is sum, right? So let's see if it works. We have, let's say, 3 elements, right? Or maybe 4 elements. 1, 2, 3, and 4. We got the sum, right? Okay. But let's say if we don't really know how many elements we have. Like, again, I put like n, right? But if it's not n, if it's something else, we just want to go through the whole vector, right? How do we do that? So instead of n, we just put vector v size, right? The size is, let's say 4, size is 4, right? So we go from 0 to 4, from 0 index to the size to the 4 third, and then we do this, which is also true. It also works, right? Well, and so on. We will get more, let's say, familiar with the things that you can do with the vector. But then let's see what else we have. So as for the array, you could put, for example, I don't know, like the size, right? You can put the size, and then you can put like some already information over there, right? But for the vector, the y is a bit different. So if you do like vector int vv, and then if you want to like make it with already or if you want to it have already n zeros, you put this, and it fills the whole vector with n zeros. 0 is just the default, but if you want to put every like to the vector, let's say not zeros but minus ones, it will put n minus minus. How can we check if there are actually like n minus ones in the vector? We just look through the whole thing without it, right? Right? So let's remove the past, whatever we had over here. Oh. So let's say we have 5 elements. Right? So it initialized itself with already like 5 times minus ones. Okay, just a second.
May I ask a question? Hello,
So
may
another
I ask?
thing, which is like small but very important information. A lot of bugs can appear in a code because of one small mistake. So this is a mistake that you learn a while, let's say, while coding and stuff. But let's try the size, right? So it will just give 0, right? Okay. What if we do -1? Wow. Right? Why? Why is it so random something? Because it's just 0 minus 1, right? Because the size is not integer. It's not an integer. It's not a regular integer. If we remember from the previous classes, not only we have int, we also have, like, for example, unsigned int, right? So because the size can't be negative, right? You can't have negative size. The size function over here returns the size in unsigned state. And when you try to do -1 from unsigned, there is no negative, and it just loops to the very maximum number. So before you do some operations, because in some cases you might want to have, let's say, condition which has something like this. To be able to do this, you change the type. You ask for the size, you get the size, but then you change the type. So it's int now. Right? So be careful about this. Know that doing minus something from the size can lead to very unexpected outcomes. So we were also supposed to talk about multi-dimensional arrays, which is basically, for example, let's say we have a array, but then, okay, a brackets brackets. What does this mean? It means for array A, in every single box, let's say, you have another array. And EG represents index EG for, like, first for the big array, you choose the E index over here, and then for the second array you choose the index over here, G, right? We will talk about multi-dimensional arrays, and then also maybe multi-dimensional vectors, as you would be able to, you know, add more vectors and then more elements to the vectors. It would look like this, but you would be able to, like, extend in this way, and then for the elements you could have But then we will talk about everything multidimensional in the next class. Like we would cover that too, additional to the next class information. I think that's it for the class. So here on code courses, where's the from the same link that I shared before for the the problem set that I shared before, right? So the next problem set that comes after, I can't find it. Wait. Yeah, this one. Oh no, not this one. Sorry. Where's it? Okay, I'll I didn't actually find it. Yeah, for example here. So from the same problem set, please try to solve the next problem set, which is about loops. For example, very simple, given a number n, print numbers from top of top. And then max. Given a number n and n numbers, find the maximum number in these n numbers. So for this, for example, we store some variable, let's call it ma, right? And then after in a for, we go through the for, we check, we input some new number, right? We check if the number that we just entered, x, is more than ma, which is equal to 0. And if it's bigger, we change the ma equal to x. And then we update it, so on, so on, so on, and then the answer is in the ma. So, please practice on the whole problem set. Try to solve everything. If you have any questions, ask. And yeah, we'll continue later with more complex and further topics. That's it for today. Thank you very much.